Osteoporosis has been a very persistent chronic health problem that is mostly observed among the women 50 age or more who experience menopause. As you know, there is no curable osteoporosis at this time. So many medicine, right? But increase the fracture and so many people. So this SAC calcium molecule treatment can curable bone mineral density is back to normal. So I think this is SAC treatment is a very significantly affect curable osteoporosis. I have just 1 hour, so I need a translator, Mr. Lee. He is better than me to speak in English fluently. Yeah, and he very well learned and understanding my research. Mr. Lee.
Thank you, Dr. Paul Lee. Good morning. It's really great to be here with all of you today. We learned so much from respected speakers, and I'm really grateful for the opportunity afforded by Dr. Homer and Mrs. Lim and the staff of IAMS and all the partnering organizations. And I'm really excited to really continue where Dr. Paul Lee left off. You can consider me as his avatar, right? I've been with him for many years, and I've been traveling and speaking about SAC calcium in his behalf. So the way we're going to do this is a little different because of the limited time that we have. Instead of going back and forth, I'm going to be just running through the slides that I'm really familiar with, and he's going to, I guess, intervene when more needs to be said or something needs to be corrected. Hopefully not, but I am just his interpreter, and we're not related at all. I'm Jay Lee, he's Paul Lee, and but we do a lot of things together as good friends. So during the presentation, if you feel like you want to hear more from Dr. Paul Lee, just raise your arms and say, Paul Lee, and Paul Lee, and he's going to come up and take over. But I'll try to do my best. So I'd like to start out by giving a little introduction to Dr. Paul Lee. He acquired his PhD in England, and he worked before for German and Japanese companies, and then established his own research lab in Canada, and he's been collaborating with different government institutions, universities, and organizations, and he held some top positions in prestigious scientific communities. He owns many patents and also published his works, and is quite well known in his field. But we're going to focus on today and just one of his invention that really opened the door to the very exciting SAC therapy. We call it SAC, standing for sigma anti-bonding calcium. And we believe this can be the next vitamin C. Now you have vitamin C, and you could have another powerful therapy that could go alongside and add on to your arsenal. And we know that there has been a lot of talk about calcium as an important supplement, and how to really regulate it has been a challenge. We talk about calcium as supplements. Some people have too little, some people have too much, but the idea of calcium therapy is new. Using calcium ion to actually treat diseases. Now that's something new to us. Dr. Lee devoted almost 10 years of intense research to discover SAC, and because of it, Calcium and Bone Health Institute was born. It's located in British Columbia, Canada, and helps so many patients with calcium-related diseases. You know, over 100 degenerative diseases are related to calcium, including osteoporosis, and we have treated over 3,000 patients. So I'm going to be asking you one question. What is the most important nutrient? And it's not calcium, right? So who can tell me what is the most important nutrient? Yes, Dr. Levy?
The one you're lowest in.
That's right, the one you are lowest in, right? But there is one mineral that is so important, it's very important, but at the same time so elusive, that one doctor can tell you that you are deficient, but another doctor can tell the same patient that you have too much. It is so important that we have more calcium than actually any other mineral in our body, and it is stored in our bones to have instant access just in case we don't have enough of it, right? And we have an organ that is dedicated to it, which is our thyroid, right? Otherwise, if you don't get instant access, your heart will stop, your muscle cannot move, and your cells cannot communicate. And when your cells divide, you're going to get a lot of errors as well. And we know that this nutrient is calcium, but not all the calcium works the same. You see, there's only one type of calcium that is physiologically active, and that is ionic calcium. So we know that Dr. Levy stated in his book, Death by Calcium, if I remember correctly, it is indeed the excess of calcium that kills a lot of people. But it is ironic at the same time that we can have too much calcium in one part of the body and then have deficiency in other parts of our body. But sometimes your body thinks that even though you have access elsewhere, that you're still deficient of it. So still stripping calcium ions from your bones. And you're intracellularly, you're having too much calcium piled up, but the body may think, oh, you still need more, right? Hence, we know that as we age, our bones can empty out. So, so and also start out with the slides that I've missed, that his work is endorsed by British Columbia, which is a province of Canada, and his research is also well-funded by the federal government, and it's also approved by Health Canada. What are the functions of calcium ions? Muscle and heart contraction. Of course, we know it's bone and teeth, blood clotting. It's a neurotransmitter, and it's also essential in fertilization, hormone secretion, enzyme activation, and immune system, cell membrane activity, cell functions, and DNA replication. There are a host of more functions for calcium ions, and it is needed for our body organs to communicate, and also in cellular level. You can see that all those activities in the cell is regulated by calcium signaling. All these organelles and the cells talk through the waves of calcium. That's why you have in your blood about 50% calcium in ionic form. And this ionic form of calcium is the only physiologically active calcium. And you also have about 45% protein calcium, which is not active calcium, another 5% inorganic calcium. Now I'm going to be showing you a quick video that shows how important calcium is. It does have subtitle.
속의 칼슘 농도가 낮아지면 왜 마비 증상이 일어나는 것일까? 쥐의 심장 근육을 이용해 칼슘이 실제 근육 운동에 어떤 역할을 하는지 확인했다.
So there's one solution with calcium ion, another solution without calcium ion. You can see when the solution with the calcium ion is flowing, the heart continues to beat. But when that is stopped, all of a sudden, the heart stops. And you can also see the heart muscle fiber inside calcium ion solution. It continues to move, but when without, you can see that it stopped. Because that's enough, right? So when calcium ion level in our body increases, right, the thyroid responds to it, and it starts a process called osteoblast, which is bone building process, and we're familiar with it. Right? We know that we have a lot of issues with osteoporosis, but let's just imagine, right? What if we can reactivate osteoblast in our body? The same way we're building bone when we're younger. We're building our bone up to age about 35, right? Every 7 years, we have entire bone turnover, and we do it about 5 times. And after age 35, 40, it plateaus, and then it declines afterwards. So when we're younger, we have osteoblast that is more active than osteoclast. Right? But as we get older, osteoclast activity goes before osteoblast. So what if we can reverse that? What if we can reinitiate osteoblast the way we're growing bones when we're younger? Is that possible? Right? We know what does that. We know by looking at this slide that if there's elevation of calcium ion in our system, then osteoblast can be turned on. So it sounds like a good strategy, right? If you want to build our bone, all right, let's put some calcium ion in our system, turn on osteoblast, and let's start building the bone. However, the calcium ion it's a very reactive metal. Right? How can we put this reactive metal in our system? So that is the challenge. But without further ado, I'd like to introduce to you one of the amazing discovery and invention we call cell calcium. We call it new invention because this is new calcium. You cannot find this calcium in nature because it employs what is called sigma anti-bonding. Now, as you can see, sigma anti-bonding is a very, very weak bonding. All other calcium, whether you find it in supplements or in food, in nature, calcium is bound by pi bonding, which is very strong bonding. That's why our body needs strong stomach acid, vitamin D, and peptide, and uses lots of ATP to bring calcium into our system. But here, this calcium is bound by weak bonding that can easily stripped off. So what is sigma anti-bonding? It is essentially the opposite of bonding orbitals, and they are formed when atomic orbitals combine in ways that is predominantly destructive. So two molecules do not want to stay together. That's why you don't find any molecule from North Pole to South Pole, wherever you go, you will not find sigma anti-bonding active. You cannot find this naturally. But Dr. Pauly devised a way to make it stable in room temperature. It is 200 times more soluble. As you can see, it has the same molecular structure as calcium carbonate. But then because of the weak bonding, it still has the charges. And these charges causes calcium ion there to interact with the hydrogen bond. And this is what happened. It has a really unique physical property. Have you ever heard of flying calcium? Calcium that flies, right? This happened in one day. Dr. Pauly left the bottle of the product open, and he came back in the morning, and this is what he found. What happened is when the water evaporates, because of the hydrogen bonding that exists, it carries the calcium ion, the calcium molecule, up in the air, but it's still heavy, right? So as soon as it leaves the bottle, it combines with the carbon dioxide in the air and crystallizes around the lip of the bottle. Very unique. If you dissolve salt and then you evaporate water, salt remains, right? Same with the sugar. This is the probably only molecule that can do this. The way this calcium is absorbed in our system is also different. As I said before, regular calcium is absorbed through active transport, which requires energy, requires digestion. But what happens is that when the calcium is brought into our system through small intestine, it goes not as calcium ion. It always goes in as protein calcium. It's calcium bound to protein, and it is inactive form of calcium. So it doesn't matter how much protein calcium you have. Unless calcium ion is extracted from it, that calcium is useless. Let's say you have very sedentary lifestyle. You're very inactive. You're not doing weight-carrying exercises, right? But you're eating lots of food that has calcium in it. So you get intake of a huge amount of protein calcium, but you're not really getting calcium ion from it. Then what's going to happen? The calcium has to go somewhere. Of course, some of that is excreted. A lot of it is still deposited in your body, causing calcification. That's the problem. But SAC calcium, because the calcium ion can be easily detached, it is actually the moment you take it, it is diffused into your system, right across cell membrane. So no vitamin D is necessary, no peptide, no digestion, no ATP required. It is absorbed without energy and as calcium ion, not protein calcium, which is physiologically active, and it starts to work right away. Now that's amazing. So this is some more technical diagram. So when you actually add 5 milligrams of SAC solution to 500 milligrams of water, we add 1:100 ratio. And sigma bonds are broken due to the osmotic pressure, and passive diffusion takes place. I'm not going to go into technical details because all of that is in the book. The book is titled SAC4 Calcium Signaling, and we actually wanted to bring this here to give to all the participants free of charge. But there was a little mishap from the printer, and it didn't arrive yet. So we will get your addresses if Dr. Homer allows, and we will ship this out to you free of charge. Thank you, Dr. Pauly. So I think it's really important for us to distinguish the difference between protein calcium and ionic calcium. Now, protein calcium does not know where to go, and it deposits in wrong places. But when calcium ion goes into our system, our body immediately recognizes it. Even the slight increase of the concentration of calcium ion in our blood, our body recognizes it. And it starts the cascade of hormonal responses that can start osteoblasts strong and start building your bone again as when you are young. And not only that, when osteoblast is initiated, your body takes all these accumulated the calcification in your body, whether it's bone spurs, wherever the calcification happened, and it starts to strip it off and bring it to where it needs to go, which is your bone. That's why we have experienced rapid bone turnover and the increase of bone mineral density. So we have actually done the animal test, and it's published, and it shows SAC calcium versus regular calcium. Its bone building power to regular calcium is almost 100 to 1. There's no comparison at all. And you can see that we have also removed the ovaries from the rat, the ovary-actimized rat. You can see here that the control bone density and the ovary-actimized rats, you can see how the bone mineral density is decreasing rapidly. But once SAC solution is added in their diet, it goes right back to the normal bone mineral density. This is a human sample where you can see that his bone mineral density, which is close to osteoporosis, is going up to normal level relatively in short period of time. You can see here, the first graph is 67-year-old, and starts from, and it has a 1.4 T-score increase in 4 months from osteopenia to the normal level. The second one, across the top, you will find that this is a 60-year-old T-score increase of 1.4 in 3 months. And bottom left, you'll see T-score increase of 1.2 in 3 months. And the last one, you can see it's 1.4 T-score increase in 3 months, and the person's age is 69 years old. Another one, 60-year-old, you can see the T-score increase from -2 to -0.6. So back to the normal level for the person's age. There's another one, 56-year-old, from -3.2 to -1.5. And you can see the dates. It's only the period of 3 months, just 3 months only. We have hundreds of these graphs. And actually, after this session, Dr. Pauly actually brought the portable bone densitometer. And he's going to be, if you're interested, he's going to be measuring your bone mineral density and give you some guidance as well. So look at this picture. This is lower jaw. With infection, you can see that even with a tooth in it, the bone eroded away. After extraction, 3 months later, 7 months later, right? And later afterwards, you can see that the socket where the tooth is pulled out is completely filled in. I have shown this picture to a dentist, and she said, "How is this possible? How is this possible? The person is almost 60 years old, and the lower jaw, which is harder to build, but then it's filling up without any other treatment, including bone graft. This is almost impossible." And this is one of the reasons why next week, the National PDA Convention will be also speaking about how we can really enhance the bone health of your alveolar bones and your jawbone. But these are the clinical proof how we can actually reinitiate osteoblasts to the point that we can actually overcome osteoporosis. These are the actual pictures that dentists can recognize. This is a patient with periodontal disease. You can see that just within 2 months, right, the bone is being built up. Here you can see that the bone is also filled after a relatively short period of time, and the T-score has improved drastically as well. Now, the calcium ion and the study of how it's related to the stem cell activation, it's been done a lot, right? So currently we are partnering together with the stem cell companies how the calcium ion can really help the stem cells, mesenchymal stem cells, to communicate and to proliferate and differentiate. And also in our mouth, we do have human periodontal ligament stem cells, right? That can be activated. So we had the cases where the patients with all the teeth are loose, right? Their teeth are tight again. And it also helps the gums to rebuild, so the gum line can go up. Right? It's bringing overall health to your dental problems and building the structure, the bone, strong underneath. Right? So that's another application of our product in the dental field. It says here that calcium ion mediated signaling is essential for the maintenance of stem cells and for promoting their development and differentiation, and also focusing on their therapeutic potential. Here was a young lady, a 10-year-old. She had bone necrosis, and the hospital recommended her foot to be amputated. After 1 month, she's free. She's still healthy. There are a lot of osteoporosis drugs out there, many different kinds. And I'm not going to list them all, but the most popular one is bisphosphonates. But the studies have shown that serious, long-lasting problems can be associated with taking bisphosphonates, including abnormal heart rhythm, incapacitating bone, joints, and muscle pain, and bone loss in the jaw. Right? And some evidence also suggests that if you're taking this for a long time, that may even increase the risk of certain types of fracture. Think about this. Your body is still taking out calcium ion because it's needed for cell signaling and muscle contracting, your heart pumping. The moment if you don't have enough calcium ion, your body needs it. But then if you artificially stop that, the body is trying to sometimes take out calcium ion at the cost of losing bone health because you need it immediately right away. But if you stop taking out calcium ion, what's going to happen to your other parts of the body? A lot of these drugs deal with inhibiting the function of osteoclast. Okay, let's keep the calcium in the bone. So let's kind of slow down the function of osteoclast. But you know your bone takes a lot of stresses, right? There are the microfractures that has to be cleared out and rebuilt again. So if you are slowing down the functions of osteoclast, what's going to happen? What's going to happen to the quality of your bone? That's why over the years, if you're taking this over the years, you could actually end up with weaker bone. Denser bone is not necessarily healthier bone. Of course, along with these drugs comes many side effects as well. So how is this absorbed? We mix this into 1:100 ratio of water, and then it expands our stomach and it is absorbed through diffusion. And often I get a question because this is calcium, in a way, supplement. We call it calcium therapy because we're just dealing with a very tiny amount. Regular calcium pills out there, you have 250 milligram, 500 milligram, 1,000 milligram, right? But we are only administering less than 5 milligrams of calcium in our system, less than 5 milligram. That's like adding only 0.1 milligram per deciliter. As you can see the graph, right? The normal calcium ion level, right? It's 4.3 through 5.6, but we're only adding 0.1. Now, do you think that's going to cause hypocalcemia? No, right? Even mild calcemia is up to 8 milligram. But what it does is because it actually starts osteoblast, it's taking all this excess calcium that is deposited in the wrong places, including mitochondria, pulling it out and clearing your system and restoring your calcium homeostasis, which is required for optimum signaling. If you have a muddied field, then calcium cannot really communicate properly. Right? If I really shout at this microphone, you're going to hear a clipped sound, and it's not clear, right? And if you have too much calcium intracellularly, and there's extracellular calcium, right? It has a good ratio, is 1:100, but then if you have too much inside, the signal cannot be clear. Calcium communicates in FM and AM, right? You need to have the optimal concentration of calcium to provide that the potential voltage potential to be able to communicate well. So by starting osteoblast and restoring calcium homeostasis, right, now your cells and your organs, your body can communicate a whole lot better. So even hyperparathyroidism patient and postmenopausal patients, by triggering osteoblasts that could really outweigh osteoclasts, you can still build bones. SAC calcium lasts about 4 hours. So that incoming calcium ion in the level that body can detect to trigger osteoblast, right, it lasts about 4 hours. There is nothing out there that can put that amount of calcium ion to start this kind of activity. Only SAC therapy can. As we grow older, our parathyroid hormone function, right, becomes inefficient. So our body kind of knows how much calcium ion we need. So it's taking out some from our bone, right? But it takes out more than what you need. Become very inefficient, right? So excess calcium excreted by the body is through the urine, but it also deposits in different parts of the body, causing unwanted health conditions. Look at these conditions: calcification of joints, cartilage, tissues, bone spurs, plaque in the blood vessels, obesity, metabolic syndrome, colon cancer, gingivitis, even Alzheimer's disease. This slide actually summarizes our point very well. Let's say even though you have excess calcium in cellular level, your body somehow perceives that, oh, right now, at this moment, I need calcium ion to pump my heart, right? So parathyroid hormone-led bone resorption takes place. Then it takes more than you need, so calcification happens, and degenerative disease can happen. That's the first one. Look at the second one. This is what a lot of people are aiming for. You have good diet with good source of calcium from food. You have magnesium, vitamin D, vitamin K, and you exercise, very good. You have less parathyroid hormone-led bone resorption. And you are utilizing more of the protein calcium yourself. Good health benefits, right? But still, slowly, as you age, you will still lose bone mineral density. With SAC calcium, you can actually start thyroid-led bone building, like when you're younger. It balances calcium homeostasis, and it could even reverse diseases. Dr. Robert Heaney said, of course, all these diseases may have many causes, but they also all have one thing in common: calcium deficiency. Again, that doesn't mean that you don't have excess calcium in somewhere else in your body. It's all imbalance. Dr. Lawrence Resnick, he is the professor of medicine at Cornell Medical College. He's well known for linking ionic calcium to the metabolic syndrome. And we talked about mitochondria, and this convention is about mitochondrial too. So let's talk about mitochondria. A large accumulation of calcium ion inside of mitochondrial membrane induces production of reactive oxygen species. It's a well-known fact, right? We talked about this. One way is, okay, let's neutralize it, right? Let's send antioxidants and then neutralize it. That's good, right? But look at this. Accumulation of reactive oxygen species in cells cause damage to DNA, RNA, and proteins, which result in cell mutation. And according to mitochondrial free radical theory, the free radicals cause oxidative damage, which is the main driving force of aging. So we are aware of the problems this can cause. If you have this, if you're over 50 and a postmenopausal woman, and then you're losing your bone density 3% a year, and you're having this accumulation in your cellular level, right, and you're producing a lot of ROS, aging happens, right? It could even result in cancer. So taking a lot of antioxidants to neutralize that is good, but establishing calcium homeostasis to reduce the very cause of the production of ROS can be another way of fighting aging. It's an interesting study. Dr. David Sinclair, he discovered that enhancing the communication between the DNA of your cell nucleus and the DNA of mitochondria, he discovered that as we age, the communication breaks down. So in his experiment, when he restored the communication, he did it with mice. He could not really tell the difference between the 6-month-old mouse and 2-year-old mouse. For mouse, 2-year-old, you're really old, right? But could not tell the difference. reestablishing the communication in cellular level is very important for anti-aging. Look at this is the actual infrared picture of a heart muscle with calcium ion drop, like 10 seconds, 20 seconds, and 40 seconds. You can see that the mitochondrial function is restored. Heat is generated. So imagine what this could do for patients with cardiovascular disease. We don't have that in the slide to show, but then we've been helping so many patients with cardiovascular disease, whether it's arrhythmia, palpitation, some mitral valve prolapse, all these. A patient who was about to die came back to life, living very healthy these years without needing surgeries. Now we're going to talk about how Dr. Raymond talked about how vitamin C can help cancer, but we can also talk about how calcium ion can help cancer. Now, a dysfunction of mitochondria could lead to the mutation of p53 gene. Now, p53 gene is the guardian of the cell. This is the gene, if there's a damage in the cell, it assesses the damage and repairs, or if it's beyond repair, it starts programmed cell death. Hence, apoptosis happens. But we know that a lot of cancer, especially carcinoma, produces lactic acid to grow and to proliferate. We know that cancer is very acidic. But cancer's acidity can be combated by calcium ion, which neutralizes lactic acid. You can see the chemical formula there, how calcium ion can come into play, neutralizing lactic acid. So cancer actually grows and proliferates by producing lactic acid and making the microenvironment more acidic. What's interesting is that when the microenvironment, the pH goes lower than 6.5, which is slightly acidic, then it actually turns off your immune response. That's how cancer can hide from your immune system. So by actually adding calcium ion and neutralizes the tumor microenvironment to ideal pH of 7.3 to 7.4, then your immune response can come back on. And your body can now see tumor and start attacking it. Now, we have done some tests with swim team. Swim is a very rigorous sport, right? So the swim team from Korea University, 20 of them, we measure their lactic acid level after they're doing the labs, right? Before and after taking SAC calcium. And you can see that there is significant decrease of lactic acid. They all improve their record. So you can find some application using this to really improve the record of our athletes. But not all cancer cells are acidic. There are cancers that are alkaline, especially sarcoma, leukemia, lymphoma, myeloma, right? Often make your body more basic due to ammonia production. The thing about calcium ion is it's magical. When it detects acidity, it neutralizes acid. But then when it finds that there is ammonia and the body is too basic, it also neutralizes ammonia to bring your pH to the right place. So let's say if you have cancer that is more basic, right? And then you were making your body more basic by drinking alkaline water and all that, that could actually hurt you more. Especially in the very last days of cancer, right? You have all different kinds of cancer, right? So if you are artificially making your body more alkaline, thinking that cancer is always acidic, then you could actually help these cancer to grow and proliferate. But by adding calcium ion calcium ion knows what to do. If it's too basic, it brings down. If it's too acidic, it brings it up. Dr. Carl Risch found out that cancer patients, a lot of his cancer patients actually displayed the similar symptoms of calcium deficiency and vitamin D. So he actually called cancer tailor-made to survive and to thrive in an ionic calcium deficient environment. See, your body can have one part that is excess in calcium, another part that is actually deficient. So it's really important to bring in calcium homeostasis and the balance and the right kind of calcium, which is physiologically active, to work for you. Otherwise, just having more calcium can actually leave you sicker. Now, many many researchers have found the important correlation between p53 gene and calcium. Now, p53 is involved in many key regulations of our cell, as you know. But it's interesting how in most human cancer, p53 gene is turned off. It means the guardian of the cell is turned off. That's why cancer cells don't commit apoptosis. It proliferates. So most cancer cells have either mutation within p53 gene or defects in the ability to induce p53. So this research focused on activation or reintroduction of p53 to induce apoptosis. And it could provide effective cancer therapy. Until now, cancer therapy relied on assault from outside. If it's radiation, it's from outside, right? It's your chemotherapy, it's from outside. Immunotherapy, it's from outside. But why not turn on the switch that our body already has? It's been turned off. But using calcium ion to turn it back on and let the cancer cell commit suicide. We have done some, again, the animal test. And we have given our calcium for about a period of a month. And then when it was given the right dosage, we have experienced that in about a third week, 70% of the tumors stopped growing or decreased in size. We're talking about just 3 weeks of time. So we have one clinical sample I'd like to share with you, though we treated many other patients. She's about 80 years old, and she was diagnosed with multiple myeloma. So this is her blood work. She was diagnosed in 2013, and look at her hematological value. It was far from normal. However, after treating with SAC for 14 months, her hematological value became normal. Look at her bone mineral density. She's almost 80 years old. November 25th, 2013, minus 3.6 osteoporosis. November 25th, 2015, minus 0.9, normal level. She's free from multiple myeloma. She's free from cancer. Her bone density is back to normal. And because of chemotherapy, her kidney was damaged, and she had only 10% kidney function, which is back to normal. She's still very healthy after all these years. Here's Mr. Kim's hematological data. You can see that his blood work is getting better after diagnosed with leukemia. How much time do I have, Dr. Homer? 15 minutes. Would this be a good time to stop and have a Q&A session? And we have actually, we had patients, not just osteoporosis, but of course it's related to arthritis, as you can see, calcium ion, right? Starting the chondrocytes to really start building your cartilage again. We have helped so many rheumatoid patients as well. Cardiovascular disease. And you also know that diabetes is also closely related to calcium ion. And we helped also many diabetic patients to really experience the normal level of sugar when it was impossible with multiple medications. But we like to open this time for questions. I'd like to invite Dr. Pauly. He is more experienced with the patient.